Hi guys, this tutorial is actually related to projection of points in detail. In this tutorial you will basically learn projection of point in first, second, third and fourth quadrant. You will also learn how to construct front and top view for different position of point. To develop better understanding regarding projection of point, please watch this video till the end. So now guys, we should understand about different quadrants before understanding projection of point. In engineering drawing, this horizontal line in the quadrant is nothing but a horizontal plane, and this vertical line in engineering drawing is nothing but a vertical plane. Horizontal plane, in short, it is written as an HP, and vertical plane, in short, it is written as a VP. Now these two planes, horizontal plane and the vertical plane, are at right angles with each other. Means they are found to be bisecting with each other. Now, whenever an object or a point or a line or a solid is lying in the quadrant, then to identify that quadrant, we should name the quadrants. This is referred as a first quadrant. This is referred as a second quadrant. This is referred as a third quadrant, and this is basically referred as a fourth quadrant. Now whenever an object or a point or a line or a solid, we will basically consider an object. Whenever an object is lying in the first quadrant, observer is this, and object is lying in the first quadrant, it is said that it is lying above the horizontal plane and in front of the vertical plane. Now when the observer's direction is fixed and the object is to be observed by the observer, then this vertical plane lies between the object and the observer. Hence, the object is said to be lying above the HP, but now it would be lying behind the VP. Means it would be lying behind the vertical plane. Similarly, for the third quadrant, the object is lying below the horizontal plane, but it is also lying behind the vertical plane. Similarly, for the fourth quadrant, the object is said to be lying below the horizontal plane, and the object is said to be lying in front of the vertical plane. This thing has to be remembered for solving the engineering problems. It can be understood easily. So we should write what we have discussed. For the first quadrant, the object always lies above the horizontal plane, means above the HP and in front of the vertical plane. Similarly, for the second quadrant, the object is said to be lying above the horizontal plane, but now it will be lying behind the vertical plane. Similarly, for the third quadrant, the object is said to be lying below the horizontal plane and behind the vertical plane. Similarly, for the fourth quadrant, we can say that the object is lying below the horizontal plane, but now it is lying in front of vertical plane. So guys, this is all about position of an object or a point or a line or a solid in the different quadrants, which is useful for solving the different problems in engineering drawing. Now consider a point A, which is lying in the first quadrant, means it is resting above the horizontal plane and in front of the vertical plane. This is referred as an horizontal plane, in short it is written as an HP, and this is referred as a vertical plane, in short it is written as VP. Now when we observe this point A from the front, means from this direction, then we can project the view in the vertical plane. Means whatever we see is a point A, that we have to project it in the vertical plane with the help of the projector. This projector is basically our assumption which has to be drawn for determining the distance only. Now let us draw the projector. The point at which this projector would be intersecting, means this point is referred as a front view, as we have observed this point A from the front, and it should be named as small a dash. Similarly, when we observe this point A from the top, Then we have the view intersecting the horizontal plane. We have to draw a projector intersecting the horizontal plane, and the point at which the projector would intersect a horizontal plane results into our top view. So let us draw it. This point is referred as an A. This is referred as a top view, and this is referred as a front view. Important point to be noted is their nomenclature only. Front view is denoted by like this manner, and top view is denoted by like this manner. So let us note down. Now, after deciding the point at which the projectors would intersect the vertical plane and the horizontal plane, the next important step to be done is to join both the projectors. Since these two planes, horizontal plane and the vertical plane, are at right angles with each other, the projector joining with each other would be also meeting each other at right angle only. So let us join them. This angle is referred as a right angle. Now, another important step to be noted is that any distance from the horizontal plane is referred as an h. Means this distance is always referred as an h, and any distance with respect to the vertical plane is always referred as a d, small d. Or else the distance from the vertical plane is d and the distance from the horizontal plane is h. This point is also to be noted. Now, another important step for converting this pictorial representation into our orthographic projection or orthographic view, we have to rotate this horizontal plane by an amount of 90 degrees in the clockwise direction. So we have to rotate this horizontal plane in the clockwise direction by 90 degree. After rotating this horizontal plane by 90 degree, these two planes lie in the same plane, and we have to convert this pictorial representation into orthographic view. That's why we are rotating this horizontal plane in the clockwise direction by 90 degree. Now, this common line between the horizontal plane and the vertical plane is referred as a reference line. It is denoted by xy. For converting the pictorial representation into orthographic view, we have to initiate it by drawing the reference line xy. Now, from the figure we can see that the vertical plane lies above the reference line and the horizontal plane lies below the reference line. Hence, the space above the reference line is referred as a VP, and the space below the reference line is always referred as an HP. Now, we have to locate this point A dash. So, we have to consider a point A dash lying in the vertical plane. Let the point A dash must lie here at a distance of h from the reference line xy. Now, important step is that we have to note down this projector also. Now we have to locate this point A, which lies in the horizontal plane. Let us see that it lies at a distance of d. Point A. One of the most important steps is that to convert this horizontal or to rotate this horizontal plane in the clockwise direction by an amount of 90 degree. Now, important point to be noted is that whenever a point is lying in the first quadrant, then front view always lie above the top view. Moreover, the projector joining the front view and the top view must lie in the same line. It should not lie at a certain distance. Means drawing the front view and the top view in such a manner, means A dash here and somewhere A here, and joining them like this. Sorry, this may be this point. This is not found to be a correct manner, but this is considered to be a correct manner for joining the front view and the top view. Hence, front view and the top view must lie in the same line. So guys, this is all about the first quadrant. An important point to be kept in the mind is that in the first quadrant, front view always lie above the top view. So now guys, consider a point A which lies in the second quadrant. Point A has been shown. Whenever a point A lies in the second quadrant, it is said to be resting above the horizontal plane, but now it is resting behind the vertical plane. When the observer direction is this and the observer is allowed to view this point A, then this vertical plane acts as an obstacle between the observer and the object or a point. Hence, for an observer to observe this point, this vertical plane should be transparent in nature. This vertical plane is actually transparent for the second quadrant. Moreover, this vertical plane is also referred as a plane of projection. So this vertical plane should be found to be transparent in nature. Moreover, it should be also called as plane of projection, on which projection of the front view has to be made. So whenever an observer observes this point A in the second quadrant from the front, this vertical plane is transparent. Now when an observer observes this point A from the front, we have a view intersecting the vertical plane at a point. Means the projector from the point A would intersect the vertical plane at a certain point, which leads us to the front view. So let us draw the projector. So let us assume that this is a projector and this point is referred as an A dash, which is referred as a front view. Similarly, when we observe this point A from the top, it would intersect a horizontal plane. Means the projector would intersect a horizontal plane at a certain point, which leads to the top view. So let us draw the projector. This point is referred as a top view and it is referred as a A. Now next step is to join this front view and the top view. We know that this horizontal plane and the vertical plane are at right angles with each other. Hence, the projectors also would be intersecting each other at right angles only. So let us join them. This is a right angle. Now, we know that any distance from the horizontal plane is referred as an h, means this distance is referred as an h, and any distance from the vertical plane means this distance is referred as a d. So let us note it down. So this distance is referred as a d and this distance is referred as an h. Now another important step is that we have to rotate this horizontal plane in the clockwise direction by 90 degree. So we have to rotate this horizontal plane in clockwise direction by 90 degree. On rotating this horizontal plane in the clockwise direction by 90 degree, since these two planes, horizontal plane and the vertical plane, are at 90 degree with each other, this horizontal plane and the vertical plane after rotation of horizontal plane becomes the same plane only. Hence, for the second quadrant, front view and the top view both lies in the same plane. Now, for converting this pictorial representation into orthographic view, we have to initiate by drawing the reference line. Reference line is a common line to both this plane, horizontal plane and the vertical plane. This is referred as a reference line. Means this line is referred as a reference line. So initially we have to draw a reference line xy like this. Now we have came to know from the pictorial representation that for a second quadrant, horizontal plane and the vertical plane lies in the same plane only. Means it rests above the reference line xy. So this space is referred as an horizontal plane also as well as a vertical plane also. Now we have to plot the point A dash which lies at a distance h above the reference line xy. So we have to plot a point A dash having the projector which lies at a distance h from the reference line xy. This is A dash. Moreover, this point A also lies in the same plane. So we have to plot a point A which lies on the same line as that of the front view, but it lies at a distance of d from the reference line xy. We have noted that this front view and the top view both should lie in the same line only. It should not be intersecting each other at certain distance. Means it should not be like this. A dash A. For a first quadrant we are considering. For a first quadrant, it is considered to be a wrong manner, and this is considered to be a second. For a second quadrant, this is considered to be a right manner. However, in second quadrant, it is not at all possible. It is possible like this. This point is A dash, and we are joining the point A like this. Then this is considered as a wrong manner, but this is referred as a correct manner. This is the orthographic view of a point which lies in the second quadrant. Now consider a point A which lies in the third quadrant. Whenever a point lies on the third quadrant, it is said to be resting below the horizontal plane and behind the vertical plane when the observer's direction is as shown here. Moreover, for the observer to observe this point A from the front, this vertical plane should be transparent in nature. Moreover, for the observer to observe this point A from the top, this horizontal plane should also be transparent in nature. Hence, this both horizontal plane and the vertical plane are found to be transparent in nature. Moreover, the front view and the top view are to be projected in the vertical plane and the horizontal plane respectively. Hence, this vertical plane and the horizontal plane are also referred as plane of projection. Plane of projection. Now, when the observer observes this point A from the front, then we have a view intersecting the vertical plane which leads us to the front view. So let us draw the projector intersecting the vertical plane at a certain point which leads us to the front view. So this point is referred as a front view, means it is A dash. Now, when the observer observes this point A from the top, then we have a view intersecting the horizontal plane which leads us to the top view. So let us draw the projector. This point is A and this is referred as a top view. Now next important step is to join this front view and the top view both. This horizontal plane and the vertical plane are at right angles with each other. Hence their views, means the front view and the top view, would also intersect each other at right angles only. So let us join it. Here actual 90 degree is not shown, but it is actually 90 degree. Okay. So we know that any distance from the horizontal plane is referred by h. So this distance is h, and any distance from the vertical plane is referred by d. So this distance is small d. Moreover, this common line is referred as the reference line xy. Now, next important step is to rotate this horizontal plane by 90 degree in the clockwise direction. On rotating this horizontal plane by 90 degree in clockwise direction, the horizontal plane lies above the reference line xy and the vertical plane lies below the reference line xy. Hence, in the third quadrant, top view must lie above the reference line and the front view must lie below the reference line. So let us join it. We have to initiate the orthographic view by drawing the reference line xy. We know that from the pictorial representation that horizontal plane lies above the reference line and the vertical plane lies below the reference line. We have to locate this point A which lies at a distance d from the reference line, and we have to draw the projector. Moreover, we have to locate this point A dash in the vertical plane which lies at a distance of h from the reference line. and join it. It is important to note down that this projector should be single only, means the front view and the top view must lie in the same line only. It should not lie at a certain distance, which we have discussed earlier. This is a projection of the point in the third quadrant, and this is referred as an orthographic view. And this is our pictorial representation. So guys, this is all about projection of point in the third quadrant. An important point to be noted in the third quadrant is that here the top view lies above the front view, while in the first quadrant the front view lies above the top view. Moreover, in the first quadrant both this vertical plane and the horizontal plane are not transparent in nature, but in third quadrant both this horizontal plane and the vertical plane are found to be right angle at each other. Are transparent in nature. Now consider a point which is resting in the fourth quadrant. Whenever point is resting in the fourth quadrant, then it always rests below the horizontal plane and in front of the vertical plane. Consider the observer's direction as this. Now, in the fourth quadrant, when an observer is allowed to observe this point A from the top, this horizontal plane acts as an obstacle between the object and the observer. Hence, in the fourth quadrant, this horizontal plane should be found to be transparent in nature. Only horizontal plane is transparent in nature in the fourth quadrant. Vertical plane is not transparent in the fourth quadrant. Hence, only horizontal plane is found to be transparent in nature in the fourth quadrant. Moreover, when an observer observes this point A from the top, then the projector intersecting the horizontal plane leads us to the top view. The projector should be projected in the horizontal plane also. Hence, this horizontal plane is also referred as a plane of projection. Now, when an observer observes this point A from the front, we have a view intersecting the vertical plane which leads us to the front view. So let us draw the projector intersecting the vertical plane at a certain point which leads us to the front view. This point is the front view, A dash. Now, when an observer observes this point A from the top, we have a view intersecting the horizontal plane which leads us to the top view. So let us draw the projector intersecting the horizontal plane in such a manner. It would intersect the horizontal plane at a point which leads us to the top view. It should be named as A. Now, another important step is to join this front view and the top view. So let us join it. As we have discussed earlier, as both the horizontal plane and the vertical plane are at right angles with each other, their views will also intersect each other at a right angle only. Now, any distance from the horizontal plane is referred as a h, and any distance from the vertical plane is referred as a d. Hence, this distance is referred as a d. Moreover, this distance is also referred as an h, or else this distance. Now another important step is to rotate this horizontal plane by 90 degree in the clockwise direction. So we have to rotate this horizontal plane by 90 degree in clockwise manner. When a horizontal plane is rotated in the clockwise direction by 90 degree, it coincides with the vertical plane. Hence, in the fourth quadrant, both the horizontal plane as well as the vertical plane lies below the reference line xy. This is the reference line xy. So for converting this pictorial representation into orthographic projection, one thing to be noted is that both the horizontal plane and the vertical plane lies below the reference line xy. So let us begin the drawing orthographic view by drawing the reference line xy. This is the reference line xy. Now we know that a vertical plane and the horizontal plane lies below the reference line xy. So this is that. Now we have to locate the point A dash, which lies at a distance of h from the reference line xy. So let us locate this point A dash lies this, which lies at a distance of h from the reference line of xy. Now we have to locate a point A which lies at a distance d from the reference line xy, means below the reference line xy. We have to draw the projectors also. Hence, this is the orthographic view of a point which rests in the fourth quadrant. In the fourth quadrant, both the front view and the top view lies below the reference line xy. Both lie in the same plane. Hence, it's difficult to get a certain understanding about the position of a point. So basically, for the projection of a point, first and the third quadrant are considered to be most favorable. So guys, this is all about projection of the point and how to construct the orthographic view in all the four quadrants. Now let us summarize what we have learned in this video. When an object rests in the first quadrant, then it is said to be resting above the horizontal plane and in front of the vertical plane. Hence, above the horizontal plane and in front of the vertical plane. Similarly, when an object rests in the second quadrant, it is said to be resting above the horizontal plane, but now it is resting behind the vertical plane. Similarly, for the third quadrant, the object is said to be resting below the horizontal plane, but now it is resting behind the vertical plane. Similarly, for the fourth quadrant, the object is said to be resting below the horizontal plane and it is said to be resting in front of the vertical plane. Moreover, for the projection of the point, first quadrant and the third quadrant are basically considered. Second and the fourth quadrant are not taken into consideration, as the front view and the top view overlaps on each other or coincides with each other. Hence it becomes difficult for getting a better understanding regarding projection of point. Hence first and the third quadrant are taken into consideration. In the first quadrant, front view lies above the top view, while in the third quadrant, top view lies above the front view. Now regarding the notations, we have discussed that if a point A has been taken into consideration, then its front view can be determined with the help of this manner, top view can be determined in this manner, and the side view can be determined in this manner. Thank you guys for watching this video. If you have any doubt, do comment in the comment section. Do like, share and comment this video, and don't forget to subscribe my channel.